by competing with people in period one. So number 2, they gave us 2 functions. If there is something just to plug into a calculator, I'm going to leave it to you guys. I'll write it down and be like, you guys can plug it. We have ln, we have 5 minus x. If you guys notice in the picture right away, there is an intersection. That's probably one of the first things you're going to find, say for maybe part A. Although actually for part A, nope, you do, because you have to split it up, call the intersection, and do this area plus that area. Anyway, long story short, anyone who's tried this FRQ, you should have found this intersection. So can someone help me really quickly? At the very beginning of the FRQ, we're not doing part A specifically, but the intersection I'm going to call x equals A. We can call x equals B if that's the one you want to use in your calculator to figure out what that is. Numbers all okay. What'd you guys get as your intersection?
3.6934414.
Okay, when I make sure I wrote it correctly, you guys can use dot dot dot, but make sure you don't write anything incorrectly. Okay, so I had A being the intersection point, being this point right here, which you can find with your calculator. Let's go. So we have ln of x and 5 minus x. Part C says the horizontal line. What horizontal line? I don't know something. Why I just said divides R into 2 regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of. I'm going to go ahead and really quickly just sketch what I saw on the page before, just for reference, that we don't have to go back and forth. So we have some sort of, and then we have, does it hit at 0? No, Ellen hits at
1.
Sorry, it's just Ellen, right?
It's 1 to
1, and then we have,
yes.
So we have 5 over here, we have 1 right here, and then we have A right here, right? So we have our ln of x, and this is 5 minus x, right? Equals, okay. Horizontal line, where? Somewhere. So just put a horizontal line and say, hey, you're okay. Okay, cool. The horizontal line divides R into 2 regions of equal area, right? But not solve an equation. So 2 regions of equal area. So I need to set something equal, right? Looking at that horizontal line, question. Where is that horizontal line in general? You're not going to be able to solve it particularly because we don't know a constant for k, but where is that horizontal line going to hit each of our functions? It's a little bit of a struggle here. Where is that horizontal line? In the first quadrant. In the first quadrant, that's 2. True. At the same y value, that's true as well. Region above is going to be equal to region below. Haven't you guys already written down the region of R? If you did part A. And in part A, you could say, okay, the region R, you put something like this. 1/2 of R is equal to, let's figure out an expression. Because R, theoretically, if you've done part A, and even if you didn't do part A, you should make up for something for part A, you can plug it in here. 1/2, what you use for A to find the area of R, should be the integral from 1 to A of ln of x, right? Because between 1 and A, look at is the area underneath ln. And then, if we were to go from A to 5, we should be using what function instead? 5 minus 6. So far we've said, okay, R has been cut in half. And what has it been cut in half by? Y. Now there are a couple different ways of doing this. However, the easiest region that I see that we could find at where we could put K in is this one. The one down below we have to do this weird, like awkward this, and then we have to do like this, and then we have to do like that. That'd be 3 integrals. This one theoretically could just be 2 split up at A. But we have to figure out what to make the bound at the left intersection of K with a function and the right intersection with K. But didn't you guys just say that Y equals K for both? So couldn't we go ahead and take the ln, and couldn't we set ln equal to And then we could go ahead and say, okay, that's going to occur when e to both sides, x equals e to the k. I'm going to use that as the intersection point for this one over here. And then, how are we going to do the intersection point for the second function, or for y equals 5 minus x? Same thing. 5 minus x is equal to k. So therefore, if I solve for x, I get x is equal to 5 minus k. So that's going to be 5 minus k, my intersection over there. So I could go ahead and say half of my whole region R is going to be equal to the integral from e to the k to a ln of x plus a 5 minus k. Oops, I said k and I wrote x. My linear function. Now this is not unique in the sense that they're the only way of solving. However, this is one way of not solving it. I apologize. I'm setting up an integral expression. However, that is one way. To say, well, if k goes through and splits it in half, then what's on top must be half of r. So take r, what you did from letter A, whatever you did from letter A, make some integral up and put it in. Half of whatever was in A for the region R is equal to the little shaded area that I wrote up above. Does that kind of make sense? You just had to figure out, well, k hits each of my functions. I got to set each function equal to k to find the x to make my values. So very similar logic. All right, that was a little bit abstract, a little bit out there. Katrina, go ahead.
What happened to the 1/2? The second part.
Oh, he's still there. I just moved the whole thing to the left because I was running out of room, but he's still there.
But like in this other part, because you
Oh,
have
no.
to.
If k separates this into two equal regions, then this is 1/2 of the whole.
Oh,
Does that make sense?
yeah.
So this side is 1/2 of the whole, which is r.
Oh,
Does that make sense?
yeah.
You could have also said that r is equal to 2 times on the other side. You could have 2 times on the other side, but I just did it that way with the 1. Alright, cool kids. So with that, we go and get rid of that random highlighting, and let's go look at number 3 in its entirety from beginning to end. I see geometric shapes. I'm not promising this is on the FRQ section this year, however, it very commonly comes up. The one thing that changes, sometimes they give you a graph of f prime, and they just make f a normal function. This one, they give you a graph of f, and then they make g an integral. Almost always, you are going to be required somewhere in the FRQ to think about, if that's g, then what is g prime and what is g double prime. Now this technically is not a part of A, so maybe that wouldn't be a smart thing to put into A's work per se. But you could maybe put it up in the graph and have it be background information. If g is equal to, so this is y equals f of x. G is defined right here. Guys, what would g prime equal just before we even start the FRQ?
That's the
From FTC, f of x. Question, what if this was an x squared? What if that was an x squared? What would g prime of x equal?
F of x times 2x.
F of
2x.
x squared times 2x, right? F of u times u prime. Okay, just double checking, just in case, depending on what you see, FTC works 2 different ways in a sense. So I have g prime of x is equal to f of x, so we can also say that y equals g prime. This is a graph of the derivative, it's just a little hidden. And how would I find g double prime? F prime, which is the same thing as the slopes of f if you need it. Okay, that's just kind of like a context of what we're given. What we're given and how to think through everything. So let's go ahead and look at part A. Part A says find the values of g of 2 and g of negative 2. So then, looking at our g of x function, wouldn't g of 2 just be the integral from 1 to 2, plugging into only the x spots, like we're used to with function notation? And guys, if you're trying to solve an integral and you don't have a function and you only have a graph, what do you need to think about? Shapes. So then if I go up here to 1, and if I shade between 1 and 2, first of all, I know that area should be a negative, right? And second of all, isn't that just a triangle? It'd be a triangle specifically with, oh, now they're getting me. So they give me the point at 2.
No. But could you take it?
So you would guess, no. Katrina, what do you think?
Could you take it out at 2, 1, and then like divide that in half?
Is it half though? Do you know that for sure?
No.
Doesn't look like half. Question. Isn't this just a line that we can figure out what the line is just by plugging into n? Or maybe even better, plugging into point slope. Any equation of a line, guys, we can find. This is literally a line. I just care about this equation and I care about what's going on at 2. This happens every now and then. Y minus y1, I think the point 1, 0 is the easiest one to plug in. So I'll plug in y is 0 when x is 1. How do I find the slope? I know 2 points.
Y1.
So I'm going to do rise, which is -1, right? Over run, which is 2. So I go down 1, right 2. That's going to be a slope of -1/2. Do you guys agree? So I can say the equation of my line is y equals -1/2 x minus 1. Why did I find the equation of that line, this portion right here? So I want to figure out what's the y value at 2. So plug in 2. 2 minus 1 is 1. 1 times -1/2. -1/2. Now, why am I showing you this? You're like, I would guess the half anyway, because if that's 1, that's half. Because I've seen FRQs where it's -1/3, and -2/3, and -2/5. They tend to be mean running for line ones. Anyway, long story short, now that we know what the point 2 is, we can say, okay, this is going to be a base of 1 and a height of 1/2. So we have a base of 1 and a height of 1/2, but this is a triangle, and what's the area formula of a triangle? 1/2 base times height. You guys can put the negative in front if you see it's negative, or you can put the negative next to the y value. Either way, you get a -1/4 for g of 2. If you want to, put a little box around it. If you want to, technically, what could you have done, just so that you wouldn't do something silly? Box it back there. That's just g of 2. How do I get to g of -2? -2. Still thinking about area, but wait a minute, hold on. We have 2 different options. One option from 1 to -2, that's backwards of what we're used to. We can go backwards in our area, and as we go backwards in our area, we can think of everything backwards, meaning what looks like a positive will be a negative, and what looks like a negative will be a positive. That's one way. The other way is to go ahead and look at the bounds and say, well, I just want to think about this normally, so I'm going to go ahead and switch my bounds and make it -2 to 1, but when I switch my bounds, I make everything negative. It's up to you. You can think backwards in the sense of switch the signs of the areas the way that they look or the way that they appear, or you can switch the bounds and say, I'll just make everything negative at the end. I see my big old triangle up above with a base of 1 and a height of 3. So that'd be 1/2, base of 1, base of 1, height of 3, minus, remember I switched my bounds, so I can say the triangle is a positive and the semicircle is a negative. Area formula of the semicircle. Area formula of the semicircle. 1/2 pi r squared. Who is r in this circle? 1, because the diameter is 2. So 1 squared. Okay, as we talked about before, let's take it to the middle. If you had thought about the other way, moving from 1 backwards to -2, you would have had a positive 1/2 pi r squared and the negative of the triangle. Positive semicircle, negative triangle, and that's exactly what this would end up being if I was to distribute it. So both of those. That was letter A. Letter B starts talking about G prime and G double prime, which would be daunting if we hadn't already thought of it. But since we did already think of it, we can go ahead and say G prime of x. I would state it here just because they might give you a point just for knowing that G prime of x is f of x. You can go ahead and follow that logic and say, okay, so G prime of -3 is f of -3. Wait a minute, isn't that what my y values are of my graph? Oh, So all you have to do is say, okay, when x is -3, f is, again, why am I saying again? Didn't give us the point at -3. Could we guess?
Yes.
Yes, but let's see if this one is exact. If I was to think about this one, y minus y1 equals m times x minus x1, which is minus -4. My slope is I rise 2 as I run 2. Well, that might not be bad then. I rise 2 as I run 2. Could be a nice test today. Double check me real fast. 5, 2, 2, yeah. So 2 over 2 is a +1 slope. So you can go ahead and say y is equal to 1 x plus 4 plus 1. If you plug in -3, -3 plus 4 is 1, 1 plus 1 is 2. They gave us a nice slope. Way too nice. Some of you might be able to follow that logic and say, hey, if that's there and that's there, halfway in between of a line, that's there. You might have gotten that, and that's okay. I'm just trying to model for you for the nasty ones where they're trying to be tricky. How to find that point if it's not nice and even with a nice even slope. So we can go ahead and say, oh, speaking of. But then they also say, find g double prime of, now they say if -3, but let's go ahead and just write the formula because they do usually give us points for the formula. G double prime is f prime, which means to find g double prime of -3, I plug in -3 to f prime. I think I've said this earlier today as a reminder, but who can tell me how do we think of f prime of -3? Slope. Isn't it aligned with a constant slope? Haven't I already found the slope with the rise over run from that line equation? Perfect. What's my slope? Or if you want to say 2 over 2, doesn't matter. Nice thing is, the box can be all nice and pretty. Guys, let me show you one thing really quickly though. If you were to box this and box that, even if you have the right answers over here, that's not good. Because that's not what they're asking. So if you are boxing, just make sure you're actually boxing what they're asking for, but just don't box anything and make it super clear what your answer is out.
Would they ever give points for trying to solve by hand, even though you could probably calculate like with this line that it was 2? Would they ever give points for writing out the work of how you did it, or not?
They would if it wasn't a nice answer like this. Like for instance on this one, it doesn't say show the work leading to, it doesn't say explain or justify. And the answer is the easy in between 1 and 3 is 2 for the linear point. So in this one it'd be fine, but there have been ones in the past where the answer hasn't been 2 and it's been instead like 5/6 or 7/6 or something awkward like that. So everyone who guessed 2 and didn't do the work got it wrong, and those that did the work got it right. So that's what I've seen more specifically. That's why I'm showing you to do the work, just to make sure. And I did the work up above because it was easier for me to show you, but hopefully you'll do the work in the question itself as it came. Part C. Find the x-coordinate of each point at which G has a horizontal tangent line. Help me out here. It's been a while since we saw this one. What's the horizontal tangent line mean? When the slope is 0. Slope of who? You should have highlighted a little more. Who has a horizontal tangent line? G. So I have to go ahead and say horizontal tangent line. And G prime equals 0. If you just say G prime is F equals 0. Which occurs if I want to know when F equals 0. And if I have a graph of F, I'm looking for the zeros of a graph are its x-intercepts. What are the x-intercepts of this graph? -1, 0, and 1, 0. So I'm going to say when x equals -1 and 1. However, it goes on. The question does. It says for each of these points, determine whether G is a relative min, relative max, or neither. And then nor max. Why are they asking that? Because we just identified our critical numbers. The derivative is 0, the critical numbers. And I can say at x equals -1, G has a relative. Now, you had no clue how to read that graph. Could you say a relative min? Since G prime goes from negative to positive, you could state a forever card and pick one. But hopefully, we'll be able to look at the graph and know exactly which one. At -1, G prime, which is F, goes from above to below. So the sign chart would have a positive derivative to a negative derivative. And as Angela's saying up here, that is your relative mass. And this super specific, you can stay at that critical number or at that critical point. And then for the second one, you guys are looking at the graph, right? What are we going to say? Does it go from below to above? Does the graph of G prime or F go from below to above or above to below? Neither. What is G prime doing?
It stays the same.
It's below to below. Since G prime doesn't, put it this way, change signs at that critical number. Now guys, remember when I go over stuff in class, I can go compare the answer key and see if you would have said it a little differently. This is what you like to scale. Basically, no sign change at once, so neither. No sign change of the derivative. At -1, relative mass, the derivative changes from positive to negative. Right.
Yeah, I put that and I got it wrong. It says that there's a something or other at x equals 1.
Did you check out the answer?
I'll pull it up. That's me.
Okay, I got it, thank you.
Okay.
1, 2, where are we at? 3?
Yeah.
G prime does not change sign at 1, therefore G has no.
Oh, there it is, right up.
Wrong, that's right.
Oh, I misread it, I'm sorry.
So good logic, you had it. You had it then. You had it then. Alright, we're on the last one for number 3. Find all values of x for which, guys, don't even look at the graph yet. G has a point of inflection. Use your further card knowledge. G, oops, say G prime, has points of inflection when you fill in actual points of inflection occur
When the second derivative changes sign.
when G double prime, which we already said is F prime, changes sign. How do I answer? Which occurs at, look at that, I already have my explanation just from the basic listing for the context of this problem. As we go up now, ask myself, second derivative, which I already figured out, is F prime. When will F prime change signs if I have a graph of F? How do I think of a graph of F if I'm thinking about his prime or his derivative? Slopes change sign. Or you can also say when F changes from increasing to decreasing, or vice versa, decreasing to increasing. So, when will the slopes change sign?
X equals -2.
Positive slope, negative slope.
And
In between is -2. This one technically could be, it's a possible inflection point, but if you see it's negative and negative, that's not going to be one. Forget that. This one, ooh, positive to negative at a D and E. And that's it. So I have one sign change at -2 and one sign change at 1.
would there be one at like 0 or where it's like down -1?
I wasn't following my graph. Yeah, good call. I have 1 at -2. F is increasing and decreasing, F prime is positive then negative. At 0, F is decreasing and increasing, F prime is negative and positive. And that one. Some of them are DNA, some of them are. Horizontal tangents. If you want to be super specific, you could say something to the effect of it's supposed to be technically at a tip when G double prime changes sign. You could say something to the effect of G double prime of -2 is DNA. G double prime of 0 is 0. I just didn't even think about that until just now. G double prime is D. I guess we could have said G has points of inflection when G double prime equals F prime changes sign at possible inflection points. Then we say something to the effect of since. To be honest, kiddos, you can go and look at the answer key. We should be totally good just by saying change of signs. I'm going to go ahead and put an X to that, which I could do on an AP, and say, you know what, this is superfluous, or this is even just plain old wrong. I don't want to take time to erase it. Let's go ahead and just check real fast. Even though our forever card says it's okay, are we sufficient just to say change signs? Yeah. Okay. The rest was just superfluous. Alright, kiddos, you guys did have a question on, let's go first to number 6, because we asked for all of 6, and then if we have time, we were going back to number 5. Number 6. Motion. This will be doing motion. Position, velocity, acceleration. Motion. Velocity. Okay. That equation. And they also give us x of 0 equals -2. When is the particle moving to the left? Second card knowledge. What do we know if the particle is moving to the left? What's negative? Velocity. So, particle, if I'm not using my favorite card knowledge, is moving to the left when v of t is negative. What am I going to say next? Which occurs, right? Sitting at my answer. I'm thinking through what the question is saying. Moving to the left, velocity is negative. Okay, cool, state that. Moving to the left, velocity is negative. Now it's time for my analysis to figure out what that is. We only have from 0 to 12, sadly it's not a graphing calculator problem. How do I make a sign chart? Find my zeros first. In between specifically 0 to 12. We're going to have to use some unit circle knowledge. We're going to have to test it on trig this way. Then I'm going to go ahead and make my sign chart between 0 and 12, putting in whatever favorite numbers I have, test the signs at B, and that will tell me moving right or left out of position. And the key is this higher. So, when is cosine 0?
6.
That's one place. Wait, hold on, you're jumping too fast. Cosine is 0. You can think of cosine inverse of both sides. Cosine is 0 at every pi over 2, right? At every pi over 2. So you can think I'm taking in a sense cosine inverse of both sides. Cosine inverse of both sides. I'm thinking a little bit beyond cosine inverse in the sense that starting at pi over 2, and I can have a whole lot more. So pi over 2 is one place, which would be approximately 1.5-ish, right? So I could say pi over 2, I could say, I can actually get my balance to work, 3 pi over 2, I could say 5 pi over 2, it's basically every pi over 2. And set that equal to pi over 6t. Question, how do I solve for t? Because I just undid the cosine. I still have pi over 16.
Multiply by 6 and
Multiply by over 6. Okay. 6 over pi. When I do the one side, I do the other. What happens is I come in. The pi's are always going to cancel in each of these expressions. I'm going to bottom on the top. 6 over 2 becomes 3. 18 over 2 becomes 9. 30 over 2 becomes 15. I have now gotten too big. All I need is 3 more, which are much nicer than I thought. If I was to plug in something in between 0 and 3 to my velocity, which is my function up here, I would plug in maybe 1. 1 pi over 6 cosine of pi over 6 is a positive, right? If I plug in 4 pi over 6 is 2 pi over 3, second quadrant, cosine is negative. If I plug in 10 over 6 is what, 5 over 3, which takes me back to the fourth quadrant, cosine is a positive. Which occurs when t is within 3 to 9. 3 to 9 what? Oh, once again, no units? No way. Oh, 3 to 9.
Where's the inverse cosine?
Basically, when we're solving the equation cosine equals a number, we have to think about what angles that's true for. And the cosine inverse is what's letting us get to the t. Cosine inverse undoes cosine. And cosine inverse asks the question, what angles for which angle is cosine to? So it's kind of like if you had a square, you would put a square root. If you had a cosine, you put a cosine inverse. In the sense of thinking through sine. Yeah.
when you're looking at or when you're doing that, can you just think when cosine is 0? Not cosine inverse, or can you just think?
I start with cosine inverse of 0 and then I broaden it. Because cosine inverse gives us one value, right? And then in order to figure out when cosine is. So technically in my math, I probably wouldn't show the cosine inverse, but I'm trying to get some people who aren't big fans of trig who can go on with me.
Okay.
Does that make sense? But if this was the AP, I personally would put cosine inverse because that's only one value. I would have just gone from that statement of 0 equals cosine of pi over 6t to, oh, that happens at pi over 2. That probably be the best way to show that. Okay, that was letter B. Does anybody find a favorite card in there? Yeah, I heard it was whispered. Total distance traveled. Good. Absolute value. You're going to go from 0 to 6 at the absolute value of v and t dt. Now be cool. Hold on. You have an expression. But what's the joy of this problem? No. It's not a calculated problem. Guys, read.
Right,
It's not evaluate. Dun, 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 dun. It's a favorite card. That's it. We got points. Maybe not tons, but who cares? We got points. Remember? To get from one category to the next besides the 1 and 5. Well, there's nothing beyond the 5 to get to them. And the 1, well, hopefully we bumped out of the 1. Because we've gone over a lot of things that we weren't so good on April 1st. This is something nice. Those categories are not very big on every point you can get. Find the acceleration. How do you find acceleration? Yeah. Acceleration is equal to v prime. Double check me real quick. V is cosine of pi over 16. Good. What's the derivative of cosine of v? Negative sine of v times e. Did they say simplify? No. So am I going to? No. There you go. But then it says, when you answer a problem, just double check me one more time. There's another part. Is the speed, hey, we did this yesterday. Is the speed increasing, decreasing in unit? Check acceleration at 4. And check velocity at 4. Right? Same sign, speed is increasing. Opposite sign, speed is decreasing. Last but not least, we'll end on D. We might go over maybe a little bit after Q's on Monday night. Letter D says find the position. Is this, oh, I just care about what's happened as over a timer? Or what's at? What's net change.
But which one?
Position at 4. If you look back at the beginning, you know the position at 0. Plug in front and dot, 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 dot. Great job, Kara. The only thing we didn't get to was the baby bird.
Tiny bird.
What's number 5? Isn't it baby bird?
Yeah.
Oh, wait, yeah. Nice, like that way all baby bird. If you guys have been absent, so if you want your stuff, I have some stuff for Sarah, Bridget, Violet, Ethan, Brenda, and Andrea. If you guys want it. No, I don't know. It's like so cute.
I at the gas station the other day.
Oh, yeah, I know.
But it was like, I saw it.
She didn't recognize it.
She's like, I was like, did she recognize her? And then they go, this is her, this is her.
Yeah.
I was like, that.
It's like you're not wild.
I learned it like 4 times. I'm like, you're fine.
Some guys are accusing me that they don't have enough time during the nutrition, so I'm in a 40 shower.
So you wasn't here, so I just.